Going to do a quick review of these two amplifier modules here. I've got the FC99 on the right hand side, and this one is labelled GF1002. Now they both use a little amplifier chip, and it's numbered PAM8406, and this module here uses the same module. Now this module I believe was a little bit cheaper, but not much cheaper. They're about the same price. The difference here being that this one has left and right volume adjusters on them, but they are these little trimmer pots, so you kind of adjust them with a screwdriver. They're not really suitable for adjusting by hand, but you can adjust the audio volume going into the amp and just have these maxed out. This one has a little on-off click switch built into a variable resistor there that will adjust the volume. So they're actually rated at two different ratings. So the rating I'm looking at on the data for this one says it is 5 plus 5 watts, so left and right channel 5 watts each. This one says 3 by 3 watts. So this one's apparently a bit more powerful. There are some little onboard components there, but nothing much in the way of a capacitor. So I've actually bung a big capacitor on the power rail there coming in. This one does seem to have a little capacitor just mounted there. So I'm going to do a few tests here, and the first test I've done is I've put them both on standby. So standby means nothing connected to the input. They've got no input, they've got no output speakers connected to them, so they're just sat there floating. Now this one's switched on. I'm reading 6 milliamps, and the other one on this side, the FC99, actually reading 11 milliamps. Now I'm reading that straight off the power supply without a multimeter. So this one in standby does appear to be wasting a lot less energy. This one's almost double. The idea with these little amplifiers here is I want to build a little stereo using some old speakers that I've recovered and probably power them off solar power. So currently this one is winning as it's got the lower standby power, so if I'm not putting any audio in, I just leave it switched on. It's using the least power from the battery. So what other tests am I going to do with these? Well, I'm going to put them under some load, put some audio into them, connect them up to two speakers, put some audio in, maybe, well, I'm going to crank them up to the top volume really, to the point that the audio starts to distort and sound horrible, crackly. Anything like that will stop. At around that point, just before it starts getting crackly, I'll take some readings from the power supply, and then we can try and calculate what kind of wattage they're actually putting out. So these are both at 5 volts. It is slightly over, but only by 0.06 or something like that. So let's go ahead and do that. The particular speakers I've got, they're pretty cheap and nasty. Well, they're free and nasty. I think there's some Bush speakers from an old stereo that has been thrown away. So salvage those speakers. They're really nothing special. They're a bit grubby in here, but there is a nice little mid or low end driver there, and a little high end driver or tweeter. 4 ohms, so quite low resistance there, easy to get some power into them, could be lower. And then there is a little kind of bass port on the back, but that's not a hole, there is some sort of cap in there and a small slot in the bottom. So we'll connect those up to these two amps and we'll take a few more bass readings, see what they're like with a bit of load on them. Just connecting up the speakers now. Always important to make sure you try and identify the polarity of the speakers. It is powered, so you can hear it buzzing away there. So on this one the yellow is negative, and I don't know whether the wire with the white strip on here is negative or positive, but in both cases I've connected the one with the white strip to negative and the other one to positive. And that's important because the polarity on the speakers decides whether or not the speaker goes in or out, and you want both of your speakers going in and out at the same time. If one of them switch the other way round, this one will push out as this one's pushing in, and they subtract from each other. And if you really can't test or measure back, what you could sometimes do is actually disconnect the speaker, connect it up the other way around, and you'll hear that in one polarity with the other speaker remained connected, you'll hear that the bass is much more vibrant, the treble sounds better. You turn it the other way and it sounds dull or almost muffled a little bit. That's when you know your polarity's the wrong way round. Okay, so I connected this speaker and that speaker to this amp, the first one, the GF1002, and I'm now reading connected to speaker, so what should I put? SK load. You can hear that one buzzing, but if I take my fingers away and it's not buzzing, this one is now taking 60 milliamps. Okay, so now time to disconnect all that and connect it up to the other one. Actually, I can probably just pull these off there, connect them up on this side. I can find my speakers. This one is negative, that one is positive, next one, the blue one, is negative, the green one is positive. I'm not using kind of a British standard colours here, but never mind. And then I need to power it, and powering it is, get this right, red is positive, brown is negative. So where does that go? Da-dee-dee-dee-dee. Up here. So I've taken the capacitor off there now, and hopefully I'll connect that up without blowing anything up. There we go. That's those ones powered. Heard it pop. Now I did notice that this one, the FC99, when I connected it up there, it did make quite a louder pop than the other one. And oh, this is interesting. With the speakers connected and no load, this one is pulling 13 milliamps. So I've gone from this one being the most efficient in standby with no output on at 6 milliamps. This one with no output was 11 milliamps. I've connected the speakers up, and now this one's actually just sat there doing nothing, putting out 60 milliamps. And this one is sat there doing nothing, using only 13 milliamps. So that's quite interesting there. You can tell this one is powered, because if I tap the inputs or rub the inputs, you can hear the noise. Okay, that's fascinating. Playing a bit of what's listed as royalty-free music on YouTube, so hopefully I can put it in my video without worrying about anything. Just playing it on quite a low volume here, and we're working with the FC99, and it's pulling about 33 milliamps. Now how far up is my volume? No way yet. I'll go as far as it says it's safe, so that's where the bar is still blue just before orange, and at that stage this one is peaking, so we'll call that medium vol. This one is peaking at about 103 milliamps. Now I'm afraid I don't have a decibel meter, so I can't actually tell you how loud this is, but reasonable. Now what I'll do is actually go up to just before it distorts and take the reading again. Okay, that was really quite incredibly loud. So these speakers aren't kicking much bass, but they do quite a good range of sound. I actually turned the phone up to maximum volume straight into this little tiny amplifier here, and it was able to drive these two speakers quite happily. They didn't sound distorted, so they could possibly have taken a bit more than this amp is willing to give, but definitely as loud as I'd want to play for any sustained amount of time. So that was quite impressive, really. So let's disconnect all this. I'll connect this one up, the FG1002, and then we'll see what that sounds like. Right, the GF1002 is now connected. The polarities are matched on the speakers. We'll just turn this one all the way up to maximum and adjust it from here. So the same track. It does sound completely different on this. It's kind of richer in the medium range. Feels like less kick at this point. And I can see that reflected on the power supply because it is drawing 35 milliamps now. That's a bit strange. It's pulling way less than it was with just the speaker load. Let me unplug the input. Yeah, so I unplugged the input. The input is basically floating high. It's now drawing 60 milliamps, which suggests that this version here has no pull down resistors on the input. So you unplug it from the device and it just floats around, and it's probably actually creating static or noise that I can't actually hear or pick up on the video, and it's now drawing 65 or 60 milliamps. Let's plug back in the audio. And we'll now go up to maximum. Oh, it's definitely distortion there. Nice bit of distortion. Let's come back a bit. Well, there we go. That was a little bit disappointing, really. So this is the new one that I've just got as a replacement to this one, which is not so common now to find. The FC99, although with nothing connected, no inputs, no outputs, sat there using considerably more than the other amplifier, the 3x3, once the speakers are connected, this one's actually much better. So the output loaded, this one is only using up 2 more milliamps, but with the output connected and the output loaded on this one, we're now using, considerably more, 52, 54 more milliamps. Then, playing at medium volume, well, this one's only using 35 milliamps, this one's using 103 milliamps. Bring the phone all the way up to maximum volume, this one's drawing 1.1 amps, and this one's drawing 0.9 amps, or 888 milliamps to be precise. So overall, this one in most conditions uses less power. That would make sense, it being a 3x3 watts. This one is a 5x5 watt and does use a comparable amount of power. It's actually much better just sat with the outputs connected, which it would be in most cases, just sat there connected to the device, connected to the speakers, not playing any music, this is quite appealing. I'm going to star that because that's what I'm mainly interested in. And actually, once we peak the power up, we're using considerably more. As you heard, this amp here did sound not very good. It was fuzzy. This one sounded nice all the way up. Nice. The bass was good on here, good bass, which is always important. And on this side it sounded okay mid, as in mid-range. So really up to you. It really depends on what you're going to do with this amplifier. I guess if you're trying to make a high-end, high-frequency type device that needs just the high range or the mid-range amplified, this is perfectly good. But my plan is to build a little solar-powered boombox or ghetto blaster type thing. I might even buy a retro ghetto blaster like a JVC or a Sony, strip out all the amplifier and everything and replace it with one of these modules, put a solar panel on the back and stick a battery in there. That would be the ultimate plan. I'm going to put one of these in the camper van as well to run some rear speakers. I might convert these to rear speakers and then be able to play via Bluetooth in the van using a little Bluetooth module. Here it is. These things are about £2. I haven't done any testing on that to see how much power it uses, but it's a nice little Bluetooth module which you can connect to and play your music straight to that, out of the headphone jack and into the amplifier and then into the speakers. Now there was one last thing I was going to do, bring up the calculator and we'll just measure the peak wattage on this. So peak wattage, well the peak on this one is going to be 0.88 times, and we'll call it 5 volts, 4.4 watts. And on the other side, the peak wattage, now this is for both speakers, la-di-da-di-dee, 5 times the 1.1 amps is roughly 5.5 watts. Now I'm not saying that is the best these amps can do, it's the best that I've got in my test, and the limiting factor in my test is the volume level that comes out of this mobile phone. If that isn't as high as it could be, obviously I'm not going to get the peak power out, so a little bit more power into that and I could possibly get 9 or 10 watts. One of the things that concern me is when it's really up high and the bass is coming out at some velocity, there's some volume, this chip gets extremely hot. So I have actually bonded a little tiny heat sink in there. It didn't quite fit in that gap, so I did have to trim it down with the Dremel and then bonded it to the top of the chip in there with a little bit of insulation or isolation between the legs of these variable resistors. So I guess that is the one I'm going to use, and I'm going to make an effort to get hold of more of these because, as you can see, tiny little module. This one does have a rather nice volume control on it, which you could probably panel mount and have the amp just sat behind, so it does lend itself to some nice little compact designs there. But actually I will stick with using this and just adjusting the volume on the phone to there, because the phone is perfect volume control anyway, and most of the things that I would plug into this would have their own volume control. So I think I'll leave it there for now and make a separate little video of actually linking this up into a little solar powered stereo system, kind of a part 2. Good night.